basics of DC machine, that is DC motor and DC generator. And in this lecture we will discuss the basic principle, construction and the types of DC motor which we people generally used. As we discussed in previous lecture that a machine, DC machine, can be known as DC generator as well as DC motor, means the same machine is used as generator and same machine is used as motor. In this lecture we will discuss what are the types of machines, but I mean to say what is the type of motors which we people generally used in industry and what are its benefits, and why these machines are divided so that and what are their use, what are their characteristics. So starting with the motors, when we talk about motor and generators, we will deal with the principles given by Michael Faraday. Michael Faraday is the basic is the scientist which discovered the laws which gives for the production of energy, electrical energy and production of torque. There are different name as Faraday first law, Faraday second law. In one of the law for the electrical generator, Faraday say that when a conductor move in a magnetic field, there is a production of EMF in the conductors. And in other way, for a motor, which we people discuss, that if a current carrying coil is placed in a magnetic field, then it experience a force. मैंने दो लॉ बोले आपको. फर्स्ट बोला मैंने, इफ ए कंडक्टर मूव इन द magnetic field, it cut magnetic lines of force, and due to this there is a production of EMF in the conductor. But in second case, when we talk about DC motor, I call as when a current carrying conductor is placed in a magnetic field, it experiences a force, and that force is given is multiplied by the distance from the center of rotation, then it produces torque at the edge. The Faraday, generally a question can be asked from you peoples, that the direction of current and direction of induced EMF and direction of torque produced in the electrical machines. We have two rules for that. One is Fleming left hand rule and Fleming right hand rule. So always remember that for generation of electricity, for a generator, there is always utilization of Fleming right hand rule, and for the motors there is a use of Fleming left hand rule. As the DC motors are generally most wide use motors in nowadays. Why I say nowadays? Because generally induction motor is generally used, but in modern application, for example your tramways, your other speed control, your small tools, for example your drilling machines, your heavy duty applications, in such machines where speed control is most important, in that case DC motors are used. Why these? Because induction motors are so robust, they are so good, their efficiency is better, but their speed control is not good. When we talk about induction motors, we have to talk about speed control, because when we go for applications, for example if you have a vehicle and you have to run it, so there is a requirement of braking, there is a requirement of slowing down, because road is never straight. You have to take turns, you have to brake for to halt your system. In such cases you need to have a good braking system, a good speed control. For that DC motors are used. What are the DC motors? DC motors are the direct current motor which convert electrical energy into the mechanical energy, and a direct current motor is fairly simple electric motor that use electricity and magnetic field to produce torque. This diagram you people have seen earlier in previous lecture. In this diagram we have we have some new things. For example, in previous diagram we don't have interpoles. There are interpoles. These things are interpoles, and these are this diagram shows the direction of the windings, how they are connected, because I have seen that the windings are connected in such a way that there is a production of alternate poles. For example, if this is north pole, the winding of this should be done in such a way that it produces south pole, because that's why due to magnetism this rotator rotates. And here with this we have given the 2 pole, 3 pole and 4 pole machine. This is the 4 pole machine. Generally poles are in even order: 2 pole, 4 pole, 6 pole. For the understanding the basic principle, we have to see this diagram, what is actually done. For understanding the basic principle of a DC motor, we have taken in previous cases that in a previous diagram we are here to produce magnets in this pole. This is north and this is south. These are all are called electromagnets. But electromagnets we discovered later, and firstly we do the experimentation on the basic magnets. Generally we have taken a bar magnet, that is one is north, one is south, and what we have done, we have taken a single coil instead of different coils, so that your understanding may be better. In this coil, if this is the direction of current, you can see is I is flowing from here. This is the direction of current. So when then there is a north pole and there is a south pole, means there is a magnetic field in this. When a current carrying conductor, means this is a conductor, and it is carrying current, means we are giving current to it, it is carrying current. That when a current carrying conductor is placed in a magnetic field, it experiences a force, means this conductor experiences a force. And if we consider that, let me take a highlighter if there is. No, in this case we can't take highlighter. If we take that this is the axis, here from here this is the axis, and from on this axis its center is there, means this is the main axis around which the conductor moves. Then this is from the center, from this center we take a r distance, r. When this force plus this r distance is multiplied, there is a production of torque, because for making torque we have to multiply force with the labor arm. Just like your door, आपका दरवाजा है वो क्या है, बंधा हुआ एक जगह से, तो आपका जो दरवाजे की चौड़ाई है वो क्या है, दिस इज ए लेबर आर्म. When you put a force on the handle of the door, it moves, and this is called a torque. Now comes to the next our types of motors. In types of motors, we have basically we can divide according to the winding. We divide the motors according to their winding connection. For example, we had divided the DC motors into basic 3 types. That is, one is your shunt motor, second one is your series motor, and third one is your compound motor. Compound means, and in this case, armature and field, both windings are connected in such a way that it is called compound motors. And starting with your shunt motor, this is called your shunt motor. Shunt means parallel. In shunt motors, the connection are given, means this is the supply, this is the current given to the motor. If this is a motor, we have to give current for it. In this case, we have connected in such a way that there is a field winding. What is the field winding? Field winding is there which is done in poles. For example, you can see from this slide that this winding is called field winding. Means इस सारी वाइंडिंग को हमने डिनोट कर दिया है एक वाइंडिंग से. इट इज हेयर, दिस इज कॉल्ड फील्ड वाइंडिंग, एंड दिस इज इन शंट. इन शंट मीन्स इट इज इन पैरेलल विद द आर्मेचर वाइंडिंग. एंड व्हाट इज आर्मेचर वाइंडिंग? द वाइंडिंग डन इन दिस इज योर आर्मेचर इज इन पैरेलल विद दिस. मीन्स इस सारी वाइंडिंग को हमने एक वाइंडिंग माना और इस सारी वाइंडिंग को भी दूसरी वाइंडिंग माना, और हमने माना कि ये दोनों आपस में किस में है, पैरेलल में. दैट्स हाउ इट मेक ए shunt machine. In this, the parallel combination of two windings connected as given, the resistance of shunt field winding is always higher than that of armature winding. You will find it is very important. You can note down this is because that the number of turns for field winding is more than the armature winding, and the cross section area of the wire used for field winding is smaller than that of wire used for armature winding. Okay, then next, here are some characteristics which might be considered later, because up to now you have not seen the equation of torque, you have not seen the equation of current, so we will discuss this later, right? First we are taking the brief only. In series motor, why this motor is called series motor? In series motor, the armature winding and your series winding, these are taken in series, means the field winding is connected in series with the armature, and current passing through the series winding is same as that of armature winding. Means since we people know that the current is series same, means जो करंट यहाँ से आ रहा है वही करंट, ये तो बंट ही नहीं रहा. इन प्रीवियस केस व्हेन वी जो करंट हमने अप्लाई किया था वो क्या हो रहा था, एक इसका वन पार्ट इज गोइंग हेयर, वन पार्ट इज गोइंग हेयर. इफ आई हैव टू राइट द केसीएल इक्वेशन एट दिस पॉइंट, अगर यहाँ पर मुझे केसीएल इक्वेशन लिखनी पड़ेगी तो मैं क्या लिख पाऊंगा कि आई एल इज इक्वल टू आई ए प्लस आई एस एच, आई एल इज इक्वल टू आई ए प्लस आई एस एच. But here in this case, if this is IA, this is the IL, and this is, matlab this I current is flowing here. If I current is flowing through this, I current is flowing through this, and I current is flowing through this. What do you mean? The current passing through the series winding is same as that of armature current, and therefore the series field winding has fewer turn of thick wire than shunt field winding. It has small turn of thick wire than the shunt field winding. Also, therefore, the field winding will possess a low resistance than the armature winding. Means the winding have the low resistance than the armature winding. And here is the characteristics which we will discuss later. And what is your third type of winding? Means compound winding. In case of compound winding, some of the part of a winding, that is series winding, is in shunt with another winding. Means compound machine में क्या होगा, short compound and long compound. You will find that what is short and what is long. In this case, this is your long shunt. Means we have one portion of winding in series with armature, means RA and RSE. One portion of winding in series with armature, and other portion is in shunt, and this whole is called long shunt compound motor. What is called long shunt. In this series winding is connected in series with the armature winding, and that shunt winding is connected in the parallel with it. In short shunt case, what is short shunt? Means we have only one part which is parallel with the armature, and the remaining part is in series with. अब प्रीवियस और इसमें फ़र्क क्या है? प्रीवियस में क्या है कि हमने इसके साथ इसको सीरीज में ले लिया, फिर जाके जो हमारा पूरा बना उसको फिर शंट किया. लेकिन इन केस ऑफ शॉर्ट शंट व्हाट वी हैव डन, we have taken parallel armature and shunt winding, and after that we use series winding. Okay, these are the cumulatively compound and differential compound. In the two winding, that is series and shunt, are wound in such a way that the flux produced by them assist the other. Means इसमें क्या किया है, देखिए आपको अजीब डायग्राम लग रही होगी, लेकिन है कुछ नहीं है कि इसमें ये आपस में शंट किया है, फिर जाके फील्ड की सीरीज किया है. मीन्स these are called cumulatively compound. Cumulatively compound means if this flux, field winding का काम क्या होता है, flux generate करना. Field winding, this field winding and this field winding, both field windings are generating flux. If all over flux, that is phi, is added by this winding and this winding, then it is called as cumulatively compound motor. But in other case, that is differentially compound, if this flux, phi flux is phi 1 minus phi 2, phi 1 minus phi 2, then it is called differentially compound. If phi is phi 1 plus phi 2, then it is called cumulatively compound motors. In next case, here we have the speed controls, but for having speed controls we have to some notations that we have to do the equivalent circuit, first equivalent circuit, but we will do it later, and we have some equations which are derived from the equivalent circuit. And next we have speed control of shunt motors. In speed control, what we have done, in order to do the speed control, we have to control the value of current. Means if you reduce the value of current given to the armature and field winding, the flux may reduce, and flux may in armature current armature winding is reduced, and which will reduce the ultimate your force, and force, if force reduce, the speed is also reduced. Means this is the flux control method. What is flux control method? Which winding is responsible for producing flux? Field winding. If you reduce the field current, then it will decrease the speed. Means this is your first control method, that is फ्लक्स कंट्रोल मेथड. अब फ्लक्स कंट्रोल कैसे करेंगे? फील्ड करंट को कंट्रोल करके. तो वी क्या किया हमने? वी इंड्यूस, वी पुट ए रेजिस्टेंस इन सीरीज विद दिस, we put a resistance in series with this, and due to this resistance the current IF is controlled, and current IF is controlled, it means that flux is controlled, and this is a flux control method. Second one is your armature control method. अब armature control का क्या है? फ्लक्स जो प्रोड्यूस किया गया, बट अगर आप आर्मेचर करंट, क्योंकि आपको मैंने बताया कि टॉर्क कैसे प्रोड्यूस होगा, व्हेन करंट कैरिंग कॉइल इज प्लेस्ड इन द मैग्नेटिक फील्ड, बट इफ यू कंट्रोल दैट करंट, मीन्स यू रिड्यूस दैट करंट, अल्टीमेटली द एफ इज आल्सो कंट्रोल्ड. इफ फॉर कंट्रोलिंग दैट एफ, व्हाट वी डू, वी पुट ए रेजिस्टेंस इन सीरीज विद योर मोटर armature, then due to this resistance your speed is controlled. Third one is voltage control. Voltage control का क्या है? If you control or reduce the supply voltage given to the motor, then it is called a voltage control method. In this method, the shunt field is connected to the fixed exciting voltage, and armature is supplied with a different voltage. Then voltage armature is changed with the help of suitable switch gear. And what is Wald-Dinard system? The system is used where a very sensitive speed control is required. For example, electric excavator and elevators. The arrangement of this system is shown in figure. That M2 is the motor whose speed is to be controlled. M2 is the motor whose speed is to be controlled. M1 be an AC motor or DC motor with a constant speed. What we are going to do means, in this case we are controlling the energy, we are controlling the value which is given to this. Means if we want to control motor 2 and we want to control this set, this is mg set, motor generated set, means this, इसको जो एनर्जी मिलेगी वो इससे जनरेटेड होगी. तो इसको जनरेटर कितना जनरेट करेगा एनर्जी, जितना इसको मैकेनिकल एनर्जी मिलेगी यहाँ से, तो हम क्या करेंगे, इसकी मैकेनिकल एनर्जी को ही कंट्रोल कर लेंगे. This system is so much expensive and generally in general application is not used. So in specific application we can use this. Flux control method. In here we have flux control method. There the diagram means we can for controlling the flux, what we people can do. This is the series motor. Means if you want to control the flux in series motor, what we do, we have a field diverter. Means we can control the value of current from here, and we in series motor also, in case of armature control, we can put a field diverter here, and in third case we can put a tapped, means this coil is tapped, we can tap इसको, अगर इससे change करेंगे तो we can change the amount of coil utilization at that, due to this we can control the field winding. If flux is less, the production of flux is less, then speed can also be controlled. Means जो हमने पहले methods पढ़े उनकी अलग अलग diagrams हैं. What is next? That is variable resistance and series with armature and series parallel control. These are the general control, and now we comes with the applications. In case of application, the shunt motors are generally used where we have to apply these motor for the constant speed application. What do you mean by constant speed? In which we don't need we don't need to change the speed of the motor, because in case of this, the same amount of voltage given to field and same amount of voltage is given to armature. In that case, we don't have much of the system by which we can control the motor's speed. Second one is here DC series motor. In case of DC series motor, the electric traction and high speed cases में generally use होती है, and DC compound motors is generally used in rolling mills and other loads requirement large momentary torques areas. Now this is the